Pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat datang ke kelas tuisyen online percuma bagi subjek Fizik SPM yang dibawakan khas untuk anda oleh Akademi Youtuber Malaysia dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Apa khabar guru-guru dan anak-anak pelajar di luar sana di mana jua anda berada? Cikgu doakan anda sentiasa berada dalam keadaan sihat walafiat. Okey, jadi cuti sekolah pun dah habis nampaknya, jadi cikgu harap anda semua kembali bersemangat untuk meneruskan ulang kaji walaupun kebanyakan daripada kita telah baru saja tamat peperiksaan percubaan SPM, tetapi jangan lupa target sebenar kita adalah peperiksaan yang sebenar pada bulan Januari nanti. Jadi untuk memulakan kelas pada malam ini, ayo kita mulakan dengan umul kitab Al-Fatihah dan bacaan doa belajar. Bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Bismillahirrahmanirrahim. Allahumma syrah li sadri wa yassir li amri. Amin, amin ya Rabbal Alamin. InsyaAllah mudah-mudahan kelas kita pada malam ini berjalan dengan lancar. Sebelum itu, cikgu ingin maklumkan kepada yang mengikuti kelas pada malam ini, anda boleh dapatkan PDF copy, student copy yang cikgu ada pinkan pada live chat. Anda boleh klik pada link, boleh download dan cetak keluar secara percuma sahaja. Anda boleh gunakan nota ini sepanjang anda mengikuti kelas pada malam ini dan boleh juga print kemudian dan boleh rujuk semula video ini nanti untuk mendapatkan jawapan yang penuh. Okey, untuk yang baru saja pertama kali mengikuti kelas kita, kelas ini adalah untuk kelas DLP, akan disampaikan dalam bahasa Inggeris. Okay, we have Jimmy there. Hi Jimmy and welcome again. Thank you very much for your support. Okay. So boleh kongsikan lagi link kelas ini kepada rakan-rakan anda. Semoga membantu dalam persiapan anda untuk peperiksaan SPM nanti. Okay, so students, saya perkenalkan diri dahulu. Yang nama Cikgu Hasnitah binti NB Mario. Kini cikgu berkhidmat di SMK Bagan Jaya, Butterworth, Pulau Pinang. Anda boleh panggil saya Cikgu Hasnitah. Okay? Dan selain pada saya, kita ada juga Mr. P yang akan kembali bersama anda pada minggu hadapan untuk tajuk yang seterusnya 5.2 Semiconductor Diodes. Okay, so pada minggu ini kita ada satu kelas sahaja, iaitu kelas tingkatan 5 yang cikgu akan sampaikan sebentar saja lagi. Okay, sebelum itu cikgu perkenalkan dahulu apps Akademi Youtuber. Siapa yang belum download, anda boleh download apps ini di Android anda. Okay, macam mana? Pergi saja ke Google Play Store, typekan Akademi Youtuber dan apa ada dalam ni, dia adalah himpunan video-video PDPC daripada prasekolah hinggalah ke pra universiti untuk pelbagai subjek. Setakat ini kita ada lebih daripada 26,000 video PDPC yang telah dihasilkan oleh guru-guru sukarelawan AYU dari seluruh negara. Okay, before that, can you give me some response, Jimmy, if you can hear me clearly? Thank you. Yang lain pun kalau anda dengar cikgu dengan jelas, boleh type dekat live chat. Clear teacher, jelas cikgu. And thank you very much for your response. Okay. Okay students, so without further ado, if you are ready and good to go, so let us begin with our lesson tonight. This is 5.1 Electrons. Okay, the first content standard on chapter 5. If you look, okay, thank you very much Jimmy. Okay. So I hope it will be clear towards the end of this lesson. Okay, so Electrons 5.1 is covered in your textbook from page 174 until page 180. Okay, you can open your textbook together with this lesson. Okay, students. So in the previous chapter, you have learned that current is the rate of flow of charges across a conductor. Okay, we've learned this in chapter reduce when a charged particles, which is electron, flow in a conductor. the question here, can electron move through a vacuum without a conductor? So what do you think? Can or not? So let's discover the answer. So these are the three learning standards in this lesson. The first one is to describe thermionic emission and cathode ray. So there are two terms there. What is thermionic emission? Second, what is meant by cathode rays? Okay, and our second learning standard, you must know how to describe what is the effect of electric field and magnetic field on cathode rays. Okay, and third is to determine velocity of an electron in a cathode ray tube. So we are going to make some calculation here, but you don't have to worry as the equation is provided, okay, in the formula list. You can check later on paper 1 and paper 2. Okay, students, let us begin cathode rays. All right, okay. Okay, so this is the first question. You can respond your answer in a if most of you have finished the syllabus in school, right? Jimmy, what about you? Okay, so what is thermionic emission, student? If you look at the GIF there, okay, when we supply heat to a metal, so what do you think will happen? Okay, so this will give you the definition for thermionic emission. So thermionic emission is a process where it is the emissions of free electron from a heated metal surface. So in simple words, when we supply heat to this metal surface, okay, at a certain value of energy, so what happened, the electron will able to escape from the metal surface. Okay, so if you look again at this GIF, the metal has a free electrons, okay, that move in a lattice structure. Lattice structure is a very well arrangement structure as metal is a solid. But students, it does not have sufficient energy to escape from the metal surface because of the strong nucleus attraction. Okay, so what happened when you supply enough heat to the metal, so this electron will acquire enough energy to escape themselves for the metal surface, so they became a free moving electron. All right. And next, this is the factor affect the rate of thermionic emission. As you can see there are four factors affect the rate of thermionic emission. The first one is the temperature of cathode. Okay, cathode is the metal connected to the negative terminal of a power supply. We call it as a cathode. Okay. So what is a cathode? When the temperature, the first factor is temperature. Okay, temperature. When the temperature increases, so what happened? The rate of thermionic emission increases, which means as the temperature is higher, more metal will be released from the metal surface or from the cathode. Okay, second factor is the surface area of cathode, the metal plate. So when the surface area increases larger, so what happened? Again, the rate of thermionic emission will be increases. When the surface area is larger, more electron will be emitted from the metal surface. Okay, the third factor is the type of metal. Students, each type of metal has a different rate of thermionic emission. So what kind of metal has a high rate of thermionic emission? For example, tungsten, we have barium oxide and strontium oxide. Okay, these are the metal which has a high rate of thermionic emission. That's why we always use tungsten in a cathode ray tube. So to produce more or to emit more electrons during the thermionic emission process. Okay, and the fourth factor is the specific heat capacity of the metal or the cathode. The lower, remember you learn specific heat capacity in Form 4 in Content Standard 4.2. A metal with a lower specific heat capacity will absorb will absorb heat quickly in a shorter time. So the temperature increases in a shorter time, which means a lower specific capacity metal has a higher rate of thermionic emission. So these are the four factors affect rate of thermionic emission: temperature, surface area of cathode, type of metal, and also specific heat capacity of the cathode. Okay, next student. Okay, now what is cathode ray? Okay, so you've understand the first term, thermionic emission. It is the process of emission of electron from a heated metal surface. Okay, next, what is cathode ray, students? So cathode ray, the electron that escape from the metal surface, we call it as a cathode ray. Okay, so cathode ray is a high velocity electron beam which move in a vacuum. So if you refer to the question earlier, can electron move vacuum? So now the answer is yes. Cathode ray or electron can move in vacuum through thermionic emission. All right? Okay. So once the electron emitted from the metal surface, so after electron has been released from the heated metal surface, it will be assembled. Okay, it will be assembled in a narrow beam as a fast moving electron. All right, and the cathode rays can be produced by using an electron gun. So this is the example of electron gun, which is also known as cathode ray tube. All right, so this is the vacuum chamber, the cathode where the electron is released from. Okay, so this is the anode, and finally there is a fluorescent screen at the end of the cathode ray tube. Okay, so I hope you are clear with the first learning standard on what is thermionic emission and what is cathode ray. Okay, students, now let us take a look at the design of cathode ray tube and how it works in details. So you can see this is the structure of cathode ray tube, and it is labeled with number from number 1 until number 5. Okay, so what is number 1 there? Number 1 is the cathode. Okay, so this is the part that heated. Okay, and as I mentioned before, normally we use a tungsten filament as the cathode. Why? Because it will produce a high rate of thermionic emission. Okay, and the second part, what happened here, number 2, the heated cathode emits electron, and this electron will be accelerated at a very high speed in between the anode and cathode because of the high voltage supply between anode and cathode. So if you look at number 2 here, we are using extra high tension, a very high voltage power supply, so to accelerate the anode to accelerate the electron or the cathode ray from cathode to the anode. Okay, and what about number 3? This is the vacuum chamber. It is a vacuum glass tube. Why it must be vacuum, students? So this is important to prevent the collisions of electrons with an air molecule. So we have to make sure it will move freely without colliding with the air molecule. So that's why we are using vacuum chamber there. Okay, and for number 4, this is the fluorescent screen. An accelerated fine beam electron will finally strikes on the fluorescent screen, and it will cause the green effect on the fluorescent screen. Okay, and number 5, this beam of electron is what we call as a cathode rays. All right. So from number 1 to number 5, it describes the structure and how does the cathode ray tube works. All right. Okay. Next, for those who are just joining us, you can get the module for this lesson from the pinned messages. It also provided in the video description below. All right. If you didn't print it now, never mind. You can print them later on. You just follow this lesson first. All right. Okay, students. Okay, now how does the cathode ray move in the cathode ray tube? So if you look at this picture, there are two regions labeled as PQ and then QR. So how does the cathode ray tube from P to Q, from the cathode to the anode? It will move in a uniform acceleration. Okay, here from the cathode to the anode, it will move with uniform acceleration. Okay, then from Q to R, what happened? How does it move from Q to R? Or from the anode to the screen, it will move with uniform velocity. Okay, yes. We also have Mr. Pei there. Hi, Mr. Pei. Thank you very much for joining us tonight and thank you for your support. Okay, so I hope you enjoy your holiday, Mr. Pei. Okay, then students. Okay, so remember, actually, this question has come out in one of the SPM trial state paper for last year. Later, we will check the question. Okay, the movement of cathode rays in the cathode. So from cathode to anode, it will move with uniform acceleration. Connected to a EHT, extra high tension, high voltage power supply, and from the anode to the screen, it will move at uniform velocity. All right, okay, students, next. Okay, so that is the first learning standard to describe thermionic emission and cathode ray. All right. So I hope you're clear with the first learning standard. Okay, now let us continue with the second cathode ray. So, and the cathode ray is a pass-through will happen to it. So we'll see it in this second learning standard. Again, this is our cathode ray tube. Okay, as you can see the GIF there. How does the cathode ray move along this tube, and finally it will reach the fluorescent student. Again, what is cathode ray? A fast moving electron which is moved in a high velocity in vacuum. Yes, very good. Okay, the first one, cathode ray, since it is an electron, so it is a negatively charged particles. Okay. Second, it travel in a straight line in vacuum. Okay. And third, it move with a high velocity. So of course, it will has a high kinetic energy and high momentum as well. Okay. And it will produce fluorescent effect on the screen. Okay. And number 5, it shows deflection in both electrical field and magnetic field. So these 5 are the 5 characteristics of cathode ray. All right. Okay. Next. Okay. So how to investigate the characteristic of this cathode ray? So we are going to discover in these two arrangement. The first one by using a Maltese cross tube. Okay, so this is a Maltese cross tube placed at the center of this vacuum chamber or vacuum tube. Okay, then the second arrangement is using the deflection tube. Okay, so this is the deflection plate connected to a positive and negative terminal. So what will happen to the cathode ray when it passes through this deflection plate? So we'll see it together. All right. Okay, students. So by using this arrangement of Maltese cross tube, we can understand that cathode ray travel in a straight line in vacuum, because once it hit this Maltese cross, so it will be blocked, so it will form a shadow on the screen. Okay. And second, later when we place a magnetic field in between this vacuum, you will see that this shadow will be deflected. Okay, either deflected upwards or downwards or to the right and to the left, depend on the polarity of magnetic field we bring near to this vacuum tube. Okay, and from this arrangement also we can understand cathode ray produce a fluorescent effect on the screen. And from the second arrangement, we will understand that cathode ray will be deflected by electric field. And since it is a negatively charged particle, so later you will see it will be attracted to the positive plate of the uh, terminal. All right. Okay. Next. Okay. So this is the observation made by using these two arrangement. Okay. So first, when we connect, okay, when we connect a deflection plate to this vacuum chamber, we place a positive plate on top and negative plate at the bottom. And there are two switches you have to see there. Switch S1 is here and second switch is S2. This switch is connected to the extra high tension power supply. Okay. And here we have another switch, student, S3. This switch is connected to an extra high tension power supply connected to the deflection tube. Okay. So what happened when we turn on S1 and S2? Mean we close this switch. Turn on mean it is closed. So when you close S1 and S2, so what happened? You will see that the cathode ray will be moving in a straight line. See the green color there? I zoom it for you. Okay, this one. When we turn on S1 and S2, so you will see the cathode ray will travel in a straight line. Okay. Okay, then how we explain this? It shows that no electrical field between the two metal plates. Okay, since S3 is open, so there is no electric field produced here. So it is continue travel in straight line. Okay, then what happened when we turn all switches? S1 turn on, S2 turn on. Now S3 also turn on, which means we turn on the deflection plate. There is an electric field exist here. So what will happen now? You will see that from this arrangement, when we place the positive plate on top and we turn on S3, the cathode ray will be deflected upward. It will be attracted to the positive plate. Why? Because it is a negatively charged particles. And when we change the position, now we place the positive plate below and negative plate on top. Now you will see that the cathode ray will be deflected downwards. It will be attracted to the positive plate. So this shows to us that cathode rays is negatively charged. Okay, simple. Okay, then what happened next? This is the second arrangement. Now we are using the Maltese cross tube, students. So we place a Maltese there, and this is S1 and S2. S2 connected to the EHT power supply in between the cathode and anode. All right, S1 only. Okay, we turn on S1 only. So what happened? You will see that a light from the hot tungsten filament will be blocked by this Maltese cross tube, and it will form a shadow on the screen. So this explains to us that cathode ray travel in a straight line. So here it will block by this Maltese, so it form a shadow on the screen. Okay, then what happened if we turn on S2 and S1 at the same time? Okay, so when we turn on S1 and S2, S2 connected to the EHT power supply. So now you will see that again, okay, the cathode ray will be blocked by a Maltese cross to form a shadow. And now it will also produce a fluorescent effect on the screen surrounding the shadow as shown in this diagram. So this is the two conclusions we can make when we turn on S1 and S2. Number one, again, cathode ray travel in a straight line. And second, it possesses a momentum and kinetic energy. And students, this kinetic energy is converted into light. So when it reach this screen. So that's why you will see a fluorescent effect on the screen. All right. Okay. Next. Okay. And this is now what happened if we put a magnet bar, okay, closer to the tube, to the cathode ray tube. Okay, and this is again the switch S1 and S2. Okay, so now what happened? We place a magnet near the tube. So this is the magnet we place near the tube. So in this diagram, we place a magnet with a north bar, okay, near the tube. So what happened? You will see that one shadow is due to the light form, okay, from the hot tungsten filament, okay, and the other shadow is due to the deflection, which means here it will form two shadows, student, as you can see in this diagram. So the first shadow is due to the light from the hot tungsten filament, showing that cathode ray is travel in a straight line. And the second shadow is due to the deflection of the cathode ray by the bar magnet that is placed near the tube. So how to know the position of the second shadow? We can determine the position by using Fleming's left-hand rule. So remember Fleming's left-hand rule we learned earlier in 4.1. Alright, okay. So if you look at this diagram here, student, this is the diagram draw to you on how to determine the deflection on the second shadow when we place a magnet bar, okay, closer to the cathode ray tube. Okay, if you remember, okay, this red line shows our cathode ray, okay, and this is the direction of current, student, direction of current. Remember, current is opposite to the flow of electron. So since electron is moving to the front, so the current is moving in the opposite direction. Okay, then if you look at the dot here, remember dot here represent that the magnetic field is out of the paper. So how to place our finger using Fleming's left hand rule? So your current means your middle finger must be pointed to the left. Okay, you can twist your left pointed to the left, and then the current pointed to the current middle finger pointed to the left. Okay, and then magnetic field point out of the paper. So your index finger should be pointed to yourself. Okay, pointed to yourself. Your middle finger pointed to the left. So you will see that your thumb will pointed upwards, which means the cathode ray will be deflected upwards. Okay, it will be deflected upwards as shown in this diagram. Okay, and the second diagram down here, this is the cathode ray move from the cathode to the anode. So the current is in the opposite direction. Okay, again, your middle finger pointing to the left. And now you see the X mark there. X mark mean the magnetic field is into the paper. Okay, so your index finger pointing to the front, out from you. Okay, pointing to the front, out from you. And then now you will see that, okay, your thumb will be directed downwards. Your thumb will be pointing downwards. So we understand this cathode ray will be deflected downwards. All right. Okay, so I hope you are clear with this, how to determine the direction of deflection of the second shadow when we place a magnet closer to the cathode ray tube. Okay, you can determine by applying Fleming's left-hand rule. Alright. Okay, now student, the third learning standard. Okay, to determine the velocity, since electron move in a very high velocity. Okay, so how to measure or how to determine this velocity? So there is a formula to apply. Okay, first and foremost, you must understand this. Okay, number one, electron that release from the cathode having an electrical potential energy. Okay, name as E. Happen to this electrical potential energy, this electrical potential energy converts to kinetic energy once they are moving. from the cathode to the anode and finally to the screen. Okay, and third, when this electron hit the screen, this kinetic energy will be converted to light energy. So there are multiple energy conversion here. Started from electrical potential energy, converts to kinetic energy, and then converts to light energy. Alright? Okay. That is the conversion of energy occur in this vacuum tube for cathode ray. Okay, next. So this is the formula we can apply. Okay, the electrical potential energy, also known as EV. Okay, and kinetic energy, formula for kinetic energy is half mv squared. We've learned in Form 4 earlier. Alright, so by this, okay, this is another information. This is the charge for an electron. Okay, we've learned this also in chapter 3 before, electricity. The charge for an electron is 1.6 times 10 negative of 19 coulomb. Okay, again, this is electrical potential energy. The formula is EV. Okay, what is E? Electrical potential energy. Small e, this is a charge of an electron, 1.6 times 10 power of 19 coulomb. And V is the potential difference between the cathode and anode. Okay, means the potential difference of the extra high tension power supply. Okay, so when we multiply this, the product will be the electrical potential energy. Okay, next, student. So how can we relate electrical potential energy and kinetic energy? It is related in this equation. EV is electrical potential energy equal to half mv squared. Okay, the maximum kinetic energy of the cathode ray. So here is the maximum velocity. Okay, so when we do the rearrangement, the maximum velocity is given by the square root of 2 EV divide m, where m is the mass of electron. And this is the mass for electron, 9.11 times 10 power of negative 31 kg. Okay, you don't have to memorize this because it will be given in the question. Just to understand the formula, how to relate electrical potential energy EV and maximum kinetic. Okay, students, what if we take a short break for a while? Don't go away, and we will be back very soon to this to see some exercises related to these topics. Okay. Okay, teachers and students, thank you very much for still with us. Okay, so we have discussed the three learning standard for 5.1 electrons, and now let us try to do some exercises with a few example of objective question. So students who are watching this lesson, you can share your answer at the live chat. Okay, so number one, the first question. Which particle escape from the surface of metal when it is heated at a high temperature? So this is a basic understanding on this lesson. Which one? Is it proton, neutron, and nucleon, or electron? Which particles escape from the surface when the metal surface is heated at a high temperature? So answer? Yes, very good. The answer should be electron. Okay, from the process of thermionic emission. So answer is electron. Okay, for those who download this PDF copy, you can write the answer there. All right. Okay, then students, next question. Okay, this is also a simple one. Okay, you are given this diagram. You can see there's in cathode, anode, and this is the high voltage. Okay, the question, what is the function of cathode? Okay, what is the function of cathode? Okay, this is cathode. What is the function of cathode? Is it A, to produce electron when it is heated by a filament? Or B, to accelerate the electron at a high speed? Or is it C, to control the intensity of the electron beam? Or is it D, to deflect the electron beam vertically? So student, what is the function of a cathode? Okay. So what is cathode? Cathode is the plate connected to the negative terminal of power supply. I think I said wrongly earlier. I'm sorry for that. Actually, cathode is a negative terminal connected to the negative terminal of a high voltage power supply. Okay, so what is the function of cathode, students? Yes, it is to produce electron when heated by a filament. So this is the filament just at the front of the cathode. All right. Okay, next. Okay, this is the third question, student. The third question. Which particle is cathode ray? Okay, which one is called as cathode ray? Is it A, electron beam? Or is it B, the gamma ray? Or C, neutron? Or is it D, the alpha particles? Okay, which one is the cathode ray, student? Okay, so the answer, very easy. It should be the electron beam. So what is cathode ray, student? Electron beam move at the high velocity in vacuum. Okay, very good. Okay, cool. The fourth question. Okay, fourth question. Okay, you are given this diagram. It shows a metal is heated. Okay, and you can see some electrons are escape or emit from the surface. So what process is referred to this diagram? Okay, what process is this? Electron is emitted from a heated metal surface. Yes, the answer is thermionic emission. Very good. Okay, thermionic emission. We've learned this before in the first learning standard. What is thermionic emission? It is the process of emitting emissions of electron from a heated metal surface. Okay, very good. Okay, now let us check on question 5. Okay, question 5. This is the diagram. It shows a multi-scroll steel which is connected to an extra high tension power supply and observed by a pupil. Okay, the shadow of the multi-scrolls will move when the bar magnet are brought closer to the tube. So we place a bar magnet north on top and south below. Okay, so which of this position, A, B, C, or D, will show the shadow, the deflection of the shadow, student? So is the shadow deflected towards A, upwards, towards C, downwards, towards D, to the left, or towards B, to the right? Okay, which one? So how to determine? Again, you can use Fleming's left hand rule. So how to apply Fleming's left hand rule here? So first, student, this is our cathode and this is our anode, which means the electron is moved to the front, to the right. So the current move to the opposite direction. So if you draw, current will move to the left. This is current. Okay, opposite to the movement of electron or cathode ray. Okay, then this is the south pole. South pole is below. Remember, the magnetic field always pointing to the south. See here, our index finger pointing to the south, means pointing downwards. This is the current pointing to the left. So which means your thumb will be pointing here to the left. Okay, this is the magnetic field and this is the force, FBI. So which means the shadow will be deflected to the left. So to the direction of D. The answer is D, donkey. Simple, right? Okay. Okay, now let us take a look at this structure question. You are given diagram 1.1 and diagram 1.2. It shows two deflection circuits. So if you look at the position here, at 1.1, it is connected to EHT of 1200 volt. And at diagram 1.2, it is connected to a HT of 2400. Okay, the deflection tube means greater voltage supply at diagram 1.2. The first question, what is a particle in cathode ray, students? Can you respond to this question? What is the particle in cathode ray? So the answer is particle. So particle is electron, okay, or negatively charged particle, which is electron. Very good. Okay, the second question, based on this diagram 1.1 and 1.2, you have to compare the value of the voltage supply and then the strength of electric field between the metal plates. Third, compare the deflection of the cathode ray. Okay, so you have to make three comparison. And then you have to relate the value of voltage supply with the strength of electric field to make a deduction on the relationship between the strength of electric field and deflection. Okay, so 5 marks there. So the blue line is for the comparison and the red line is for the relationship. So how do we relate? So based on diagram, voltage supply in diagram 1.1 is less or smaller than that in diagram 1.2. Simple. Okay, just see here, 1200 volt. Here is 2400 volt. Okay. Second, compare the strength of electric field. So what happened? Definitely, the strength of electric field in diagram 1.1 also will be less than diagram 1.2 since lower voltage supply. Okay, then third, compare the deflection of the cathode ray. So deflection of cathode ray in diagram 1.1 also will be less compared to that in diagram 1.2 or vice versa. You can also write 1.2 greater than 1.1. Here also diagram 1.2 greater than 1.1. Deflection also you can see 1.2 greater than 1.1. Okay, what about the relationship? Okay, relate the value of voltage and the strength. So from here you can see when the voltage supply is decreases, so the strength of electric field also decreases, or vice versa. You can say the other way around. When the voltage supply is increases, the strength of electric field is increases. Okay, the word increases can be replaced with greater. Okay, and the word decreases can be replaced with smaller as well. Okay, then compare, relate between strength and deflection. So again, when the strength of electric field decreases, so the deflection also decreases, or vice versa. You can say when the strength of electric field increases or greater or higher, so the deflection of cathode ray also increases or greater or higher. All right. Okay, simple. Students, so from here we gain 5 marks, 3 from the comparison, 3 from the relationship. Okay, so now let us take a look at the 7th question. Question number 7 is taken from SPM Trial 2023 from Kedah State. Percubaan SPM 2023 Negeri Kedah. Okay, so this is diagram 7.1. It shows an electron beam that accelerated from the cathode to the anode in the vacuum space, and given the potential difference across the electrodes is 500 watts. Okay, so the potential difference between cathode and anode is 500 volt. All right. Okay, so first, state the type of motion of the electron beam which move across the electrodes in the vacuum space. So student, they ask you for the type of motion. Remember earlier the type of motion from cathode to anode. How does the cathode ray move from cathode to anode? Okay, is it uniform acceleration or uniform velocity? velocity. Which one, student? From cathode to anode. Very good. The answer is uniform acceleration. Or you can say velocity increase uniformly. Moving in a straight line also acceptable. Remember, the cathode ray move in a uniform acceleration from the cathode to the anode, and from the anode to the screen, it move with uniform velocity. All right. Okay. Then next question B. Calculate the maximum velocity of the electron across the cathode and anode. Okay, how to find maximum velocity of electron moving from cathode to anode. So this is the information given. We are given the mass of electron m and the charge for an electron e. And we are given here 5 potential difference. Okay, so this is the formula. EV, electrical potential energy, equal to maximum kinetic. Maximum velocity is determined from the square root of 2 EV divide m. Okay, 2 EV divide m. So this is 2. This is E. What is E? Charge for an electron. And this is V, the voltage, okay, of electron. So you just press your calculator, okay, and the answer is 1.325 times 10 power of 7 meter per second. So this is the maximum velocity of the electron across the cathode and anode. Okay, next. Okay, this is question C. You are given diagram 7.2 now. Okay. Then you are given table 1 as well. Table 1 show the characteristic of heating element for P, Q, and R. So this is where we place the heating element, student. The heating element is placed in front of the cathode. So when we heat up this heating element, it will release electron from the cathode. Okay, and the electron will be moving in a straight line towards anode. All right. Okay, so you are given 3 choices. Heating element P made of tungsten and the shape is coil. Second, you are given with heating element P made from copper and it has a coil shape as well. And third, you are given heating filament R made of aluminium and it has a straight shape. Okay, it does not coil. Okay, so which one is your choices, student, for making the heating element? Okay, first, type of material, which one? Is it tungsten, copper, or aluminium? Okay, which one is the best material to choose? Okay, Jimmy, what do you choose? Is it tungsten, copper, or aluminium? Okay, the rest also you can give your feedback. So I know who are there following me just now. So we choose tungsten. Okay, why choose tungsten, student? From the previous discussion, because tungsten has a high resistance, or it is a high resistivity metal, so it supply more heat. Or also you can write it has a high rate of thermionic emission. Okay, so more electron or more cathode ray will be released during the process. Okay, then what about the shape, student? Coil or straight? So definitely we choose a coil shape. Why choose a coil shape for the heating element? So when we choose coil shape, the length will be longer. So when the wire is longer, means it has more resistance, high resistance, or more heat will be produced by the heating element. More cathode ray will be released from the surface. So from here, which one is the best choice? Definitely, obviously, you can see the best choice is heating filament P. Okay, simple, right? So now Next question, students. Okay, this is question 8. Our last question for tonight. It is taken from Percubaan SPM 2023 from SMKA and SABK. Alright. Okay, so the first question, you are given diagram 4.1. It shows a simple cathode ray tube. Consists of filament, cathode, anode. Alright. Okay. It say that cathode emits electron when switch P is closed. Okay. Cathode emits electron when switch P is closed. Okay, first, name the process that enable the emission of electron at the cathode. So they ask you to name the process, student. Name the process that enable the emission of electron at the cathode. So what is the process? Emit electron at the cathode. Yeah, very good, Jimmy. It is tungsten. Okay. So name the process, student. What process involved here? The emissions of electron from cathode. So the process is called, yeah, very good, thermionic emission. Okay, thermionic emission. Okay, question B. When electrons flow in the cathode ray tube, the current produced in 5 seconds, this is the time, 0.01 ampere. Okay, so this is the amount of current produced at 5 seconds, 0.01 ampere current produced. So you have to find or calculate the total charge of the electron. So now find the charge of electron. Remember, in electricity, student, how to find charge of electron. So charge is Q. Remember, charge is Q. You are given I. This is I, the current, 0.01. And this is the time, T, 5 seconds. So you are having T, I. How to find Q? So how to relate the three? Q, I, and T. Remember the formula we learned in chapter 3? Charge is given by Q, I, T. Q equal to IT. Q is the charge, I is the current, and T is the time. So you just do the substitution. The current is 0.01. The time is 5 seconds. So how much charge? 0.05 coulomb. Okay, 0.05 coulomb. Simple. Alright. Okay, next. Question C. Yeah, very good. Thermionic emission. Thank you, Jimmy. Okay, next. Question C, students. Now you are given diagram 4.2. It shows a passage, incomplete passage in an electric field. Okay, so in diagram 4.2, you have to complete the path of the cathode ray. So actually this question relate to the deflections of cathode ray in electric field. So first you have to look at the plate. Okay, the top plate is connected to the positive terminal of the EHT. So top plate should be positive. Okay, and the bottom plate connected to the negative terminal of the EHT. So this one is negative terminal. And remember, our cathode ray is an electron, a negatively charged particle. Okay, negatively charged particle. Okay, negatively charged. So where does it deflected? Upwards or downwards, student? This one. It will be deflected upward or downward. Okay, definitely it will be deflected to the opposite terminal, means to the positive terminal. So it will be deflected upward. Yes, very good. So you have to draw a line from this end, show it deflected upward to the positive. And students, when you do your drawing, make sure it touch the plate. Make sure the cathode ray touch the positive plate. Pastikan dia sentuh permukaan plat. Alright? Okay. Second, Give one reason for your answer. So why you draw it upwards? Why it deflect to the positive plate, student? This is very simple. This is because electron is a negatively charged. Okay. Cathode ray is a negatively charged electron which will attracted to the positive plate. Simple. Okay. Yeah, very good, Jimmy. Q equal to IT charge equal to current multiply time. Alright. Okay, next student. Okay, question D. Okay, question D. You are given the potential difference across cathode and anode is 550 volt. Oh, this is V, potential difference. And given the charge for one electron E is 1.6 times 10 power of negative 19 coulomb. And mass for one electron is 9.11 times 10 negative 31 kilogram. Yeah, it will be curved upward very well. Right? Okay, so the first question, calculate the electrical potential energy for one electron, student. Find electrical potential energy for one electron. So remember, in the third learning standard, what is the formula for electrical potential energy? E. So E equal to EV. Okay, E equal to EV. Okay, you have to add some more terms there, Jimmy. Attraction to the positive plate because cathode ray is a negatively charged particles. Okay, so it will be attract to the positive plate because it is a negatively charged particles. Okay, okay. So how to find again? Electrical potential energy E equal to EV. Okay, what is E here? Charge for one electron, and V is the potential difference between the cathode and anode. So you just do the substitution. Okay, this is E, electron, and this is the voltage. So the answer is 8.8 times 10 negative 17 joule. Okay, so this is the electrical potential energy for D1. Okay, next, using this formula, half mv squared equal to EV. So EV is here, electrical potential energy, and this is the kinetic energy, okay, half mv squared. So find the maximum velocity for an electron when it reach the A naught. Okay, students, so how to find? So this is the equation you are given. So EV, we calculate earlier, 8.8 times 10 negative 17. Alright? Okay. Yeah, good, Jimmy. So we rearrange this formula, making V max, maximum velocity, as the subject. So it is equal to the square root of 2 EV divide M. What is E? This is the charge for electron. This is the voltage and mass as well. Okay, so this is answer. EV here, 8.8 times 10 negative 17. So this is the mass for one electron, 9.11. Sorry, I missed another one then, 9.11 times 10 negative 31. So the final answer is 1.39 times 10 power of 7 meter per second. Okay. So students, I guess that's all the discussion and exercises on 5.1 electrons. They are learning standards, so I hope you can master them very well, and all these exercises I hope will help you to understand 5.1 electrons in a better way. Jadi cikgu rasa itu saja perkongsian untuk malam ini. Alhamdulillah kita dah berjaya habiskan 3 standard pembelajaran dan melihat beberapa contoh latihan dan percubaan negeri Kedah dan untuk SMKA Sekolah Menengah Agama dan juga SABK Sekolah Agama Bantuan Kerajaan. Okey, jadi terima kasih kerana bersama-sama dengan cikgu daripada awal sehinggalah kini. Cikgu harap perkongsian ini sedikit sebanyak banyak bantu kepada yang belum lagi cetak keluar, anda boleh klik pada link PDF dekat video description pun ada. Okay, just check this video later on, so anda boleh cetak keluar dan jadikan dia sebagai bahan tambahan untuk ulang kaji anda. Cikgu harap bahan yang cikgu sediakan ini membantu anda untuk menambahkan koleksi latihan, dan jangan lupa bersama-sama kami lagi pada minggu hadapan akan diteruskan oleh Mr. P. Tajuk yang seterusnya 5.2 subjek tingkatan 4 akan bersiaran pada hari Jumaat 9.30 malam. Dan untuk subjek tingkatan 5 kita akan bersiaran pada hari Ahad. Sesungguhnya yang baik itu daripada Allah SWT, segala yang kurang itu daripada kelemahan saya. Dan cikgu ucapkan sekali lagi terima kasih, dan teruskan bersama-sama kami guru-guru fizik di Akademi Youtuber sentiasa akan membantu anda untuk persediaan anda, untuk anda faham subjek fizik ini dengan lebih baik. Because kalau anda sedar atau tidak, actually we are very close. Our daily life is very close to physics itself. A lot of things we see, we do every day can be related to physics. So letaklah fizik itu dekat hati, minatlah subjek ini. Saya percaya anda akan faham kenapa kita perlu belajar fizik ini. Again, thank you very much Jimmy and everyone out there. Terima kasih kerana bersama-sama dengan. Jadi itu saja untuk malam ini. Semoga kita berjumpa lagi dalam masa yang akan datang. Assalamualaikum, salam sejahtera dan selamat malam semua. Bye-bye.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.